or 819.24 times 10 to the power of minus 9 meter to the power of 4. Okay, so the first term up here, this is the power of 3. Okay. Right, so now we know that IZZ1 is equal to IZZ2. Okay, so we know that the width is equal to what? The width is equal to 80. The depth is 9.5 cubed over 12 plus by the area, which is 80 multiplied 9.5. And then the distance is equal to 120 or 60 plus by 9.5. So this distance over here, right, is equal to 120 divided by 2 plus by 9.5 divided by 2. Okay, so it's equal to 120 over 2 minus, not plus, I do apologize, minus, no, plus, because it's up to here is plus by 9.5 divided by 2, and then the whole thing is squared. Okay, so this will be equal to 120 divided by 2 plus 9.5 divided by 2 squared times by 80 times by 9.5 plus by 80 times by 9.5 power 3 divided by 12 is equal to 3.192. Okay, 3.192 times 10 to the power 6 millimeter to the power 4. Let me try again. 120 divided by 2 plus by 9.5 divided by 2 squared times by 80 times by 9.5 plus by 80 times by 9.5 power 3 divided by 12 is equal to 3.192. Okay. Then we have to calculate IZZ3. Now IZZ3, the centroid, the local centroid and the global centroid are the same. So we only need to do the width, which is equal to 9.5. Depth is 120 cubed over 12. Okay. So this is equal to 9.5 times 120 power 3 divided by 12. So it's equal to 1.368 times 10 to the power 6 millimeter 4. Okay, let me do it again. 9.5 times 120 power 3 divided by 12. Yep, 1.368. So now we know that IZZ is going to be twice of the 3.192 times 10 to the power 6 plus by 1.368 times 10 to the power 6. Okay, so this will be equal to 2 times 3.192 power 6 plus 1.368 power 6 is equal to 7.752 times 10 to the power 6 millimeter 4, or 7.752 times 10 to the power minus 6 meter 4. Okay, so this value are the important values now. Okay. So you have IYY, which is equal to 819.24 times 10 to the power minus 9, and you have IZZ, which is 7.752. Okay, so you have to, now we are coming back to this formula over here, right? We are coming back to this formula over here where PCR is equal to pi squared E IYY. The other one is pi squared E multiplied by IZZ. So you can see from here, we have to pick the what? We have to pick the lower value to calculate the factor of safety. Okay. I will use two values, and then I want you to see why we have to use the lower value. Okay. Okay. So now I'm going to calculate based on XY plane, and I want you to look at XZ plane also. Okay. So we are going to do two planes. Okay. So we are going to calculate based on XZ plane. And then we are also going to calculate on the XY plane. So we know we are going to calculate the critical load, which is equal to pi squared E I forgot I what I y and this one over L squared. And the other one, okay, I'm going to call this, rather it can be confusing for all of us. So I'm going to calculate the critical load on the XY plane. And then we are going to calculate the critical load based on the, XZ. This is XZ plane. And this is the XY plane. And this is equal to pi squared E IZZ over I, or over L squared. So we know that our pi squared is the same. Our Young's modulus that is given to us is 200 times 10 to the power 9. Our IYY that we calculate, okay, which is equal to 8.19 times 2.4, or 819.24 times 10 to the power minus 9. Divide the equivalent length, or the L, is equal to, we are given, is equal to what? Is equal to 6. Okay, this is equal to 6. So this will come out to be 3 pi squared plus 200 power 9 times 819.24 power minus 9 divided by 6 is equal to 269. It's equal to 269 point, wait, pi squared. Oh, 6 squared, Eugene, come on. So pi squared times by 200 power 9 times by 819.24 power minus 9 divided by 6 is equal to, so it's 44.9 9192. Okay. Okay. So this IYY is lower than the IZZ. So what will happen if you use IZZ? Okay. So as you can see, this is also equal to pi squared. Young's modulus is 200 times 10 to the power 9. IZZ. Now IZZ is equal, we calculated the IZZ. IZZ now is equal to 7.752 times 10 to the power minus 6. Okay, 7.752 times 10 to the power minus 6. Then this will be divided by 6 squared. Okay. So pi squared times by 200 power 9 times by 7.752 power minus 6 divided by 6 divided by 6 is equal to 15. No. Shift pi 7.75. So I think I pressed my calculator wrongly. Times by 200 power 9 times by 7.752 power minus 6 divided by 6 divided by 6. And this is equal to 425.051 times 10 to the power 3 Newton. So you can see now the valid critical load. Okay, so this is the valid critical load. Okay, and this is invalid. Why this is invalid? Because on the XY plane, right, the critical load where buckling will occur is 44.92 times 10 to the power 3. If you were to apply a load of 425.051 times 10 to the power 3 Newton, what will happen is the XZ plane will buckle already. Okay, so let me calculate it. Shift pi squared times by 200 power 9 times by 7.752 power minus 6 divided by 6 divided by 6. Yep, 425. Okay, so this is not the right value to use, as you can see now. Okay, so towards the end, we are going to calculate factor of safety. is equal to 44.92 times 10 to the power 3 divide. So let me write out the formula. Okay, so this is our pre-critical and divide by our P. So this is equal to 44.92 times 10 to the power 3 divide by 16 times 10 to the power 3. So this is equal to 44.92 divided by 16 to the power 3 is equal to 2.81 or 2.8075. So I'm going to call it 2.81. Okay, that is our safety of factor. So we have designed this structure such that under the load of 16 times 10 to the power 3 Newton, the factor of safety is 2.81. Okay, we cannot use this value because it's way too high. And as I explained to you, if this is the critical load, if we were to use the critical load for the XY plane, okay, which is 425.051, the exact plane will buckle already. Okay, I hope you all can visualize this. Okay, any questions so far? So I don't hear any one of you have any question. The most critical thing about this example, okay, is this. Okay, what do we mean by IYY and what do you mean by IZZ? I've been teaching this course. This is my 14th time, I think. 12 or 12 or oh wait, 12 or 13th time. Usually students get mixed up with IYY and IZZ. Okay, so to do IYY, the first thing that you do is you sketch out the axis of interest. Okay, and then the parallel geometry is known as the width. The perpendicular is known as your depth. When you always do this, like over here, IZZ is the geometry of axis of interest. Parallel to the axis is the width. Perpendicular is the depth. Whenever you do this, you will never go wrong. Okay. Now the next thing that we are going to do, okay, the next thing we're going to do is a very important aspect of buckling. Okay. The resistance of how the structure will buckle is not just based on the length, not just based on the Young's modulus, or not just based on the cross-sectional area. It is also dependent on how both ends are fixed. I repeat again, it's also dependent on how both ends are fixed. Okay, and this is what we call extension. Okay, extension of Euler's formula. Okay. So, as I say, the resistance to withstand buckling is not just based on Young's modulus, not just based on the length, it's not just based on the cross-sectional area, but also how the ends or the structure ends are held. Okay, so what do I mean by that? Okay, what do I mean by that? So let's look at condition number 1. Okay, let's look at condition number 1. Okay, let's look at condition number 1. So I'm going to get condition number 1. Yeah, all these images are provided on Avenue to Learn. Okay.